Hello, this is help for Unit 2, Lesson 8. And what I'm going to do, I've got A, B, C, D. I'm going to do it in help you in one video here because they're all kind of related to each other. So we want to determine the parametric equation. So it's a different form, parametric, for the following planes. So for B, we want the plane containing two intersecting lines. So they tell us that these two lines intersect already, okay? So our plane equation, since these two lines intersect, I don't have to find the intersection point. Okay? They tell me it intersects, so I just need a point on the plane. So for my parametric, my reference point, I'm just going to use one of the points from the line, because that line is going to be on it. Now, after that, I can pull my two direction vectors from those lines. And again, we got to be careful here. They've used the variables t and s. I can't use those again. So I'm going to use the first direction vector here. Let's go with an m. So plus 4m minus 2m plus m. And then the second direction vector, minus 3n plus n plus 4n. So there we go. We know the lines intersect. Don't need to know the intersection point. I'm going to use the reference point from one and then the direction vector from each. C, plane containing the line. So we're going to use that line and that point. So we need to have a point and two direction vectors. So at this juncture, I've got my reference point. So that's taken care of. And I've got direction vector 1. I need to find a second direction vector. So my second direction vector is going to come from, and I'll give you a sketch here. So here's the plane. I want to find the equation of this plane. It contains the line that was given, and we want to include this point. So I'll have the first direction vector from the given line. If I take the reference point from the given line and use my new point that I'm going to use, this will give me a second direction vector. So I can take the point 835, subtract 1, 3, negative 1, and I get my second direction vector to be 7, 0, 6. So that would mean that the equation for this plane, from parametric, I'm going to use the reference point, x equals, y equals, z equals, and again, I'm going to use m and n. So 1, 3, negative 1. So that's from that reference point there, plus 2n, plus 2n, minus 5n, and then the new direction vector that was developed, plus 7n. I don't need to add it here, plus 6n. And that gives you your parametric equation for C. Then finally, let's look at D. So what do we have with D? I'll give myself a bit of a picture here. So here's the plane. I've got two parallel lines. So what that does for me, I'm going to have two potential reference points. Oops, but I don't have a direction vector, so that shouldn't have gone in there. Because the second direction vector is parallel, that's no good for a plane. So I'm going to take the reference point from the first line and the reference point from the second line, and that will create my second direction vector on the plane. So that would mean that my second direction vector will equal first reference point minus, second reference point minus the first one. Doesn't matter the order really. And I end up with negative 2, 4, negative 8. And of course you can simplify that or reduce that to lowest terms. But for our purposes here, x equals, y equals, z equals. So I'll pick the reference point from the second line just to mix things up a little bit in the example. And then my two direction vectors, like I said, it doesn't matter which one I pick. So for instance, let's pick that one. So we'll have plus 6m minus 4m plus 4m. And then my new direction vector, minus 2n plus 4n minus 8n. And there we go. We now have a plane that contains both of those lines. So very, very similar. They're related to each other, obviously, because they're the same question. Just a couple of tips that you can create or find that second direction vector even with two parallel lines by using those reference points. Hopefully that helps. If you have any questions or follow-up questions, let me know.